gaman að sjá ykkur svona mörg hérna. Ég heiti Helgi Björgvinsson og forstöðumaður sölu hérna á hugbúnaðarlausnum Advanja. Í dag erum við með Brúum bilið á milli þróunar og reksturs. Eða bara DevOps og svona hvaða áhrif sósíalbreytingar hafa haft á tæknina. Fyrirlesarinn okkar í dag bara einn, það Dave Pemberton. Dave is API Management, Hybrid Integration, Microservices, DevOps, IoT, RPA. These are some of his specialties. So his title is similar to that of Þórdís Reykfjörð Gylfadóttir, whatever her name is. He has the longest title on LinkedIn. API Integration and IoT Practice Manager. Us here at Advanja first met Dave in Stockholm some months back, and we thought his knowledge and presentation skills were of such a good standard, and his material so interesting that we thought we'd just bring him to Iceland and let you guys hear what he has to say on those subjects. So Dave, welcome.
Thank you. So let me introduce myself first. If the slides work. Okay, excellent. So I'm Dave Pemberton. I'm from the UK, soon to be ex-member of the EU at some point. Who knows when that might be? It could be next week, it could be 3 years' time, who knows? So I work at Software AG, and I work in our professional services team. So I've spent 19 years of my life delivering integration solutions for customers, both big and small throughout the UK, but I also cover the Nordics and the Netherlands as well. I've spent time in India, in America, working with multinational companies, trying to help them to improve the way they work, particularly in line with our software. But actually what I'm going to talk about today is more around things about how we do the software, not the software itself. So I'm not going to try and sell our software to you. What I'm going to do is explain what we do and why we do it, and try and give you some thoughts and insight into the things we do that you can take away. So the first presentation, we're going to talk about how architectures are changing. So how people and how technological changes are affecting architectures throughout time. And I pose this question first. So the world evolves around us always, right? So every day we discover new things. So last year there were 18,000 new species of animals discovered in the world, right? 18,000, which is a crazy amount. And people arguably get more intelligent, and are definitely growing taller, with the exception of me, right? But I come to the Nordics or to here, and people are sky high above me. So we as a race are evolving. The question I tend to pose is, are we evolving, or is technology evolving us now? Because if you look at the way things work and what we do now, it appears that technology is changing the way we behave and the way we work, and is evolving us in different ways than biological evolution. So I'm going to give you a walk back through time, and then I'll explain why I'm going back through time. So in 1970, we started off in the period around the industrial IT, and there may be a few of you in the room who remember punched cards, and you're feeding punch cards into big mainframe computers that filled rooms in buildings, had massive ventilation. I'm actually lucky enough not to remember that period. It would scare me, I think, trying to feed paper into a computer to make it do something. But that's where kind of the dawn of the IT era started. You move forward to 1980, and the home computers appeared. So people remember things like the BBC Micro, the ZX Spectrum. All those computers started to appear in people's homes. And sure enough, what happened was it transitioned from dumb terminals in offices to PC-based computers at that point in time as well. So people then started using terminal emulators on the computers. But your data was stored on a cassette, right, which took 10, 15 minutes to load something in there. Or if you were lucky, you could start using discs, 5 1/4-inch discs, 3 1/2-inch discs, and you had a massive 720K, right, on a 3 1/2-inch disc to store. 1990 was roughly the dawning of the internet. And this is when people like AOL and CompuServe joined together to create the World Wide Web. So rather than having separate bulletin boards, the World Wide Web appeared, and it changed the makeup of IT. You know, no longer was it just universities or large organizations that could connect into a global network. Everybody around the world could connect into that global network. And you know, we got into crazy eras here, right? We had CDs that stored 650 megabytes worth of data, and people at the time said, how the hell will we ever fill 650 megabytes worth of data? This is crazy, we can't do that. And of course, we found ways to fill it. You get to the year 2000, and the year 2000, early 2000s is when the smartphone started to emerge. So right, you can look, if you look back through history, you can look around 2001, 2002, when the first smartphones actually started to appear. And you know, that changed the way we do things again. So now people have got a computer in their pocket that's more powerful than the home computer back in the 1980s, right? So now you're carrying around something in your pocket that has infinitely more power than where we started in business. And if you look at storage again here, now we've got things like pen drives, flash cards, micro SDs, all those things with ridiculous amounts of storage on them now, right? So now you can get micro SDs up to 256 gigabytes of storage on them in something that's, you know, 5 millimeters long. So it's changed again, and we have these massive volumes of data. And if you look now, moving forward again, we hit the IoT era, and the IoT era introduces all of the different cloud services. So now storage is defunct, right? Nobody uses storage anymore. Nobody has pen drives generally. People put things on Amazon Cloud or OneDrive or the Apple versions of the different technologies that allow you to share files like Dropbox. Nobody now will put files onto a pen drive and hand it over to somebody. They'll send them a link to it and they can go and download it off the internet. And we have now unlimited storage. So people can save files on Amazon. You buy a mobile phone from Google, you get Google Drive storage. You buy from Apple, you get the Apple storage. You buy an Amazon Prime account, you get unlimited Amazon Drive storage. So people now have access to unlimited storage. Let's overlay generations of people onto this. And again, I don't know if you use these terms in Iceland, but these are recognised as generations of people in the UK. So we've got Generation X, which is, they are considered very pessimistic, right? And I scrape into Generation X, by the way, so I fall in that area. So Generation X are considered pessimistic, whereas Millennials over here are considered optimistic. So they have a different outlook on life. And Zennials fall somewhere between those two, right? So you can see that you've gone from pessimism to slightly less pessimistic to now everything's going to be great in the world. And if we look at Generation Z generally are the children of Generation X. Now, why is this interesting? So, the average age of someone in IT right now is 42, which puts them down here, and that's the average age of someone working in IT right now. So that means the average person in IT remembers a time pre the internet, remembers a time almost, or remembers the early home computers, remembers being able to develop something that fits in small disks and small storage and so on. But new graduates that are coming out of university right now are towards the end of the millennial era, and they'll shortly be hitting the Generation Z era. And those people don't know a time without mass storage, don't know a time without the internet, don't know a time without smartphones. So they have massive expectations on what IT can give them versus what I have down here, because I've grown up with it. So the people from here onwards, any potential recruits, any companies we're working with, all these people here have an amazing thirst for technology, but also an expectation of what it can deliver. They expect to be able to pick up their iPad and click and link things together and create something. They expect to be able to create something within minutes and have it deployed and running and improving the business. Whereas everyone from Generation X thinks it's going to take 6 months to get something built and deployed and put it into production. So we have to keep evolving because these people are going to drive us forward. And you'll see here, we can then overlay architectural styles onto this. So predominantly back in the early days, people built client-server applications, right? So generally you started off with an application on a mainframe and terminals that talked to it. So it was sat on one big huge server. People realized that wasn't so great, so we started to build fat clients. People developed Visual Basic applications or some other godforsaken technology to build a big, huge application that talks to a database on the mainframe or a mainframe itself. And we built big, fat client servers. When the internet came around in 1990, everyone said, fat client servers are rubbish, let's do a thin client, let's use the browser, let's build a thin browser-based application that talks back to a server. So something to say with Microsoft ASP or Cold Fusion or JSP or any of those technologies were built applications to create a thin client server. And then people realized actually again that was a bit futile, because what you're doing now is in essence you're creating a thin client server, but your server's still got everything in there and it's one single point of failure. So people then decided to create what is pretty prevalent right now, a layered architecture, where you've got a series of layers to try and break down what you build to give you some sort of segregation and some sort of control over how these things are deployed, and to give you scalability, because the thin client servers were pretty unscalable. And when you get to the size and scale of the internet now and the amount that people expect, you expect more scalability. And the last architecture is the newest, which is what's called a serverless or a Lambda architecture. And this is in its infancy right now. But if you use things like AWS or Azure, you can spin up on demand instances of something, use it, and then turn it back off. And that's what's called a serverless architecture. So you don't have these things running. They start and execute and stop as and when you need to do them. And that's kind of what a serverless architecture is. And you see this is dawning now. This is growing in its use across the industry. But if you look again across the generations, you'll see here that people here, new graduates, they are pretty much being entrenched in the layered architecture. But they will grow into this, whereas people prior to this don't even, graduates don't care about big fat clients or don't care about mainframes, right? If you showed a graduate a mainframe, they wouldn't know what they were looking at right now. They would think, oh, that's just green text on a black screen, right? They wouldn't have a clue. So, what we do is evolved by technology always, right? So you look back at a car factory, X number of years ago, people built them by hand, and now we build them with robots, right? So the technology itself evolves what we do, and it's the same with software. The question is, how is this relevant and why? So, the industry is evolving, right? As I said, new generations don't understand a life without a smartphone. New generations of people do not have to remember things, right? They Google it, they get out their phone, they find the answer on the phone, whereas when I was a child, you had to store the thing in your head to be able to do it. Now you don't, right? If you don't know how to write something in code, you go on the internet, you find any of the websites that give you a code example, and you can pull it off and just use it straight away. So you don't have to remember and drive these things. And actually, it makes them better in some ways, because they are able to find and consume things much more quickly than somebody from previous generations, because they know how to find things and how to consume data, whereas people from previous generations do not. What is interesting is that people are now taught programming at a very young age. And if you look at this chart here, this shows the age distribution of people doing MIT Scratch, and you'll see that it peaks around 13 years old. Now, my daughter is 8 years old, and she's done MIT Scratch, and she's done Python at 8 years old, right? Which is crazy when you think about it, given that people of my generation didn't start programming until they were, if in school it was sort of 14, 15 years old, whereas now children are taught programming from an early age. And this creates that expectation, right? They want to be able to link things together and to do things and to drive computers in a way that they can. And they want immediate results. They don't want to have to wait to get these things happen. They want immediate results. And you'll see how the industry is changing as well. So this is from GitHub. So GitHub every year create what they call the Octaverse. And they look across their previous year and they assemble different projects to work out where the trends are. And if you see down here, this is the top 10 trends from GitHub from 2018. This is actually different than 2017. They change every year, so it's always worth watching. But you'll see, number one is a framework called React, which is built by Facebook. And React is a usability, user experience framework to develop web apps for users. And you'll see that is number one, front and center on GitHub in terms of the most used project and the most, the most downloaded, most used technology in GitHub itself. And you can look and work out that user experience covers actually 3 of the top 10. So you've got AngularJS hiding in there. You've got Electron, which is another usability framework that I never heard of until I looked at this chart, right? I'd never heard of Electron. But you'll see that user experience is front and central in 2018 because people want to have a better user experience. These millennials and these Generation Z people want to be able to just pick up and use this thing. They don't have to expect to learn how to use a computer program. They expect to be able to pick it up and just be intuitive and use it. And that's why user experience is front and central. You'll notice platform, there are two of those in there. Node.js is growing massively in terms of its scope and its breadth and use across the industry. But number 4 is one that is interesting, is Docker. And Docker appeared probably 3-4 years ago in its infancy and has grown and matured in a massive way and is changing the way we do things as well. And we'll go into Docker more in the next presentation. You can see iOS and Linux in there as well. But you can see here how they all relate. So you can see, for example, we're talking user experience, we're talking platforms, and we still hang on to API and integration. So API is at number 10 in the most used terms from GitHub itself. And you can see here some of the trends. So you'll see, for example, that TypeScript, which is related to Angular, has jumped up from number 10 down to number 7 in terms of the most used language. But and you'll see here that the fastest growing languages over here, right? So if you look here, the fastest growing languages are Kotlin and HCL, which again are unusual languages: Rust, CMake, Go. So these might be languages that you don't recognise, but are languages that the new generation are using. So people love writing GoScript, for example. Python is as popular now, if not more popular than it ever has been, mostly because of things like machine learning and math algorithms and those other things that appear with it. But again, it gives you kind of a view on where things are. And JavaScript has been number 1 for a long number of years, as has Java. But you'll see declines in C. Ruby has really tailed off. So Ruby was popular once 5, 6, 7 years ago. But you can get a good trend again here about what's happening. And this is important to recognise that all these things appear, right? People want to use these technologies. People want to build things in these technologies. So you can't stop them from doing that because you will constrain what they want to do and the speed at which they can do it. So, talking about the speed, let's talk about the Netflix effect. So Netflix is an organisation that was built from the ground up. I mean, they were lucky, right? They were a greenfield organisation. They could do what they wanted to, and they built their architecture in the way that they wanted to do that. Most companies don't have that benefit, right? Most companies have a massive legacy and a massive history, and you can't just rip it all up and start again. Netflix came out of nowhere. But you'll see a BBC News article here from last year that says Netflix is going to pose a challenge to British TV, right? My kids don't even understand what a TV schedule is, right? They expect TV on demand. They want to load up YouTube or Netflix or Amazon Prime and watch something whenever they want to watch it. I can't explain to my 4-year-old son why he has to wait for something to be on the TV. He just doesn't understand it. He expects to consume it. But Netflix is changing the way people consume media. But they have to keep keen, right? Because Disney are sitting right on their tails now. Disney are about to launch their own streaming service, and that could actually harm Netflix because a lot of Disney content's on Netflix. So whilst Netflix are the darling of the media industry right now in terms of what they do in terms of TV, Disney could come back and bite them, right? So Netflix, even though they're the winner right now and they're the leader, they can't rest on their laurels. They've got to keep moving, keep improving, keep changing, because others will come up against them. And it shows that Disney are a long historical company, right? But they can get somewhere near where Netflix are and can challenge them. Amazon, another really good example. And Amazon is killing the UK high street, right? The UK high street is in decline because of companies like Amazon, which people of my age may say that's a bad thing. People of younger age say, actually, well, we don't care. We just want the convenience to buy online and get it delivered next day and get it at the best price possible. You see, Amazon has taken 5 times as much new warehousing space this year as anyone else. This was from 2017, I think, in terms of UK warehouse space. So Amazon has more warehouse space than anybody else, and they took 5 times more in one single year. So you can see how Amazon do this. Amazon work at a massive pace, and I'll show you that in a second. This is actually a Software AG customer, so this is a customer I work with quite a lot. So Walgreens Boots Alliance are a big pharmaceutical chain that cover the UK, Spain, and the US. So Walgreens is the US, Boots is the UK. And you've probably seen Boots stores in airports. If you've been to the US, you can't miss Walgreens because they're on every corner of every street. to talk about the Amazon effect, Amazon bought an online pharmacy company called PillPack sometime last year, and overnight Walgreens lost 11 billion of their shares value overnight because Amazon bought a pharmacy company. Because the fear is that Walgreens are a large behemoth of a company that can't move quickly, that will fall by the side, and if Amazon are going to move into pharmaceuticals, Walgreens' day is over. And that's why overnight they lost 11 billion in market value on one day, which just kind of shows the dangers of people like Amazon and Netflix and those other companies that are driving it. So, what do we do about this? So we need speed. Each of these things in the jigsaw are contributory factors in new architectures. So things like microservices, things like containers, things like APIs, cloud, DevOps, IoT, all these things are there to drive innovation and to drive user experience. And all these things are all pulled together to create a seamless experience. Look at some examples of companies, and these are real examples. So cars.com do 300 deployments a year, right, which is about one every day and a bit, right? 300 deployments a year, and I will bet that many people in this room are nowhere near that, right? 300 deployments in a year, but that's not that many. Flickr do 10 deployments a day. So you think 10 deployments a day, that's quite a lot, right? Etsy, an online retailer, 50 plus deployments per day, right? And now you can start trying to think in how many minutes between each deployment, right? And then we get to the extreme example, Amazon. Amazon do a deployment every 11.6 seconds. So whilst we've been talking, I couldn't even work out the maths to work out how many deployments they've done since we started talking. But that shows how they're at the top of their game and how they can change what they do immediately to actually change the business and to move the business forward. And you think, you see this and you think 300 a year is good, but this is at the extreme end. And to be able to keep up with that pace of change, to be able to innovate and innovate at the edges and provide a better experience, companies need to move down this line to be able to be, to get towards where Amazon are and where Netflix are and those companies. If you want to compete with them, you've got to be as quick as them and as smart as them to an extent, otherwise you will fall behind. So, progression is unstoppable, right? You can't stop this. And it's not just the people that are driving progression, it's the technology, it's the whole markets around what's happening. And development continues to evolve, right? So if I said the word enterprise service bus or ESB, people would say, yes, we use that, right? I would say that's a legacy technology, a legacy term. An enterprise service bus is an old style way of building applications. And I'll talk about this a bit more in the DevOps presentation. But Software AG no longer uses the term enterprise service bus unless a customer requests that they want to buy an enterprise service bus. We don't talk about it in that language anymore. The whole language has changed. What you don't want to do here is to be that dinosaur, right? Dinosaurs were huge. They were massive. They had great big huge teeth and were pretty scary. But they became extinct. And what survived? Those little mammals, right? Those little shrews and the little mammals in the line that survived. And they turned into something much more useful. So you can think about this in technology terms, right? This may be the big legacy beer moth and the little shrews that survived and the little rodents that survived and turned into what we are. Those animals were the tiny little microservices and the little things which could survive the what happened in terms of the progression. So application development evolves, right? So historically, applications shared nothing between vendors, right? So there was very little common frameworks. Everyone built them from the ground up always. Whereas now, and again, if you see the term, I use the term apps now, not applications, right? So everyone talks about apps now. Apps are now built from the best of breed, open source frameworks, services, APIs. Nobody now writes an authentication mechanism anymore because you can offload it to Twitter or to Facebook or to LinkedIn or wherever. So if you're trying to build something on the web, most people do not bother writing authentication now. Nobody writes address lookups because you can offload that to somewhere else, whereas historically you'd have to grab an address file and put it locally. Nobody writes their own credit check code because you can offload that somewhere else as well. So you can assemble an application from all the best of breed things and turn that into something which is much more useful. Again, historically, applications were built specific to the platform, whereas now they run in sandboxes or containers. So now you can put it on any platform and you shouldn't care about where it's going to run. And more so, applications were monolithic previously, built for a single purpose, whereas now they have APIs in this line to exchange data and to allow that data to be opened up and allow that data to be used across your estate. So, in terms of how you can change this way, so I've got a little recipe in terms of what we're going to do to try and improve this. So these are the ingredients. So these are the market forces which we see driving software AG. I'm not going to go into all of these, but in essence, the most important ones we see generally right now are integration, API, microservices, IoT, and cloud are the general ones which are having the biggest effects on us right now as a company, and are where we see most of our requests from organisations. Now, APIs and integration, this is a quote from Gartner, and it's a great quote, but APIs and integration are almost exactly the same, right? People talk about integration, people talk about APIs, but they are two sides of the same coin. You know, an API is just a way to call integration. Integration is just an API, ultimately. Doesn't matter how you dress it up, they are one and the same thing. You have an API to provide integration. You have an API to provide a point into a system. Integration calls APIs. So you have both together always, generally. So here's the new architecture style. And this, again, has appeared within the last year or so. This is what's called a mesh app service architecture. And in this mesh app service architecture, what you see is you have a series of outer APIs. And these outer APIs here are APIs specific to the device which is consuming them. So an API for a mobile device, an API for a machine, an API for a robot to consume, an API for an IoT device. They're built specifically for those devices. They aren't the APIs that are the inner APIs, which are down in your systems down here. So you have the inner APIs exposed as microservices or mini-services or macro services, and we'll get to that as well, that are exposed from your systems, and even APIs you build, but you break the chain, you don't connect those end callers to those APIs, you create an outer API, and you shield the inner APIs from there to give you some kind of indirection, and to allow you to change different systems down here at a different pace, and change the experience of the application up here by changing the APIs. And what you do in essence is you create a mesh application in this scenario, so you can mesh a series of APIs and systems and applications together to create an application for an end user. And then you can use those same APIs, and maybe different consumers, to create a different application by meshing them in a different way. And this is what's intended for by a mesh architecture itself. You need an API gateway and a mediation layer sitting between these two endpoints to be able to allow you to provide innovation and experience at different rates here than you can down here, because these systems down here you can't always change quickly. Whereas what you will want to is to provide innovation at the user edge and innovation at the experience edge, to be able to give a different front on what might be behind the scenes. And you'll see, again, talking about the ESB is a monolithic architecture, right? So this is talking about microservices now. An ESB scales by copying everything time and time again, right? So you need big fat servers all the time with all the things in there to be able to scale it. And it doesn't matter if I've got a HR service used by 5 people or an e-commerce service used by 5 million people, they're all scaled at the same rate in an ESB. And therefore, you end up with masses of servers that might not always be used. And to give a ridiculous example, the tax authority in the UK has 82 servers providing integration for 2 days of the year. The rest of that time they can run it on 2 servers, but they stand all 82 for the entire year, which costs them an arm and a leg in support money, in terms of the physical power up of those machines and the maintenance of those machines and so on, all for the end of tax period. And that's because they take this approach. Whereas if you build a microservice style architecture, you scale the services according to their need. So if you've got a 5 user service, you can have 1 or 2 of those. If you've got a 5 million service, you can deploy as many of those you need to scale outwards. And you scale the individual services versus the whole thing. And that's why you take microservices on board. So you build microservices to do certain things. And as I said, people choose the best of breed choice that's dependent on their requirements. And it may be our software from Software AG. It may be they choose to use Spring Boot or AWS Lambda services or Node.js or any other technology that can provide a microservice. But in essence, people build microservices across the bottom. Of course, you've got those big back office systems, those black box applications, right, that are sitting there forever, that you can't move forward. How do these take part in the new world? Now, there are 2 ways. So the first way is to microservice, the application, microservice-enabled application using standard integration techniques. So you can put an integration platform in place to connect to that, expose them as microservices, push it to the gateway, and then now you've got a series of APIs that can take part from here in the new world. But that's not always possible, right? Because these applications can be from the dark ages, they have no way to get into them, they have no APIs, and sometimes the only interface to them is the user interface, right, or the terminal on a mainframe. And therefore, the only way really you can do those is to use a robot, right? And it sounds horrible, but it's one of the only few ways you can get in when the only interface is the user interface. So use a software robot to drive that user interface. You then expose that as APIs, and then people can carry on and use APIs again as they were before. But you have to remember what that's doing and what performance metrics you will get from that. But sometimes that's the only way to actually enable those things if you can't break into it any other way. So then, once we've got all those ingredients, we mix it all together, right? And how do we do that? So, you create what are called mini-services. And mini-services are essentially orchestrations of microservices. So you connect microservices together to create something more useful. So each of these microservices can be quite simple, right? It could be log a message, it could be log in, it could be get a user. But actually a mini-service says, I want to be able to get a user plus all their order details. So that can call more than one microservice to be able to get that data back and provide that back as a mini-service. And again, you'll see APIs are front and center in this architecture. To get mini-services, again, there are two ways of achieving this. There's a classic developer approach where you build classic integration. There is no one single solution to this. Again, everybody does this differently, but you can build classic integration to connect the systems together. The second way is the new way, and this is trying to encompass that new generation of people. So what people want is and it's a term called citizen developer. A citizen developer, somebody who hasn't necessarily studied in IT but expects to be able to click these things together, wants some way to create an application. They want to grab their iPad and connect some things together and get some data out, and they want it now. They don't want to wait for IT to deliver this in 10 years' time. And if you don't give them the facility to do this, you'll see spreadsheets appearing and access databases and all the other things appear where people are creating these things. So you can use newer techniques that you can use to be able to create mini services in a browser in seconds and link these things together. And again, this is one example. This is the Sarah example here, but you can do that within minutes and expose that as an API. So then you then bake all those ingredients after you've mixed them all up. And I'm not going to go into this right now much because I'm going to talk about this in the next presentation, but we've got agile development and DevOps are two important things, and I'll come back to this afterwards, and containerization, and we'll explain those in the next presentation. The final bit is the decorate. So you've got your cake now, and what you want to do is make it pretty, right? So you want to put some icing on the top and make it look pretty and make it look like it's useful. And that's what's called a macro service. And the macro service consumes mini services, which consume the micro services, and then you get this mesh type application that you're creating. Now, a macro service, generally, there are two ways to build this as well. There's a developer approach, and these are what I would call a single page application, using things like React or Angular or Vue or Polymer or whatever other framework you want to choose. And it's interesting when we talk about single page applications because what they've done in essence is create a fat application again, because a lot of the responsibility that was back on the server before now moves into the application. So you'll find business logic creeping into things like a single page application now that runs in the browser. So you'll find heavy JavaScript with business logic in there. So you can see a shift again in the way where things are lying in terms of what happens. Because single page applications often orchestrate the services together to make what they want to happen. So you find logic moving again. But these things are free from any constraint, right? And these give you the ability to build a user experience particular for your organization and to be able to differentiate yourself. The important thing here actually is that there's often an abundance of skills in these areas, right? You'll see lots of people with the title full stack developers, lots of people that can do this sort of build. They're normally quite inexpensive as well. So it gives you a way to create a very good looking application that differentiates you based on your end services. The other way is using a citizen developer approach where you can pull the systems and service together in a UI where you can create things like processes and expose things as dashboards and expose them into different UIs to create a separate view. This is a more constrained view because obviously you can't cover up everything. You can't get the same sort of expression you can in a build it yourself type view, but this gives that citizen developer again the ability to control and build these things on their own way. So final thoughts on this presentation that I'll leave you with before we move on. And this is something I've seen in the industry a lot over the years. The shifting of influence and the balance of power has changed in IT over the years. So when I started, architects and operations were king in IT. Architects decided what was going to happen, operations controlled all that thing. Right now, what I see is business and developers have more influence than architects and operations. So developers get to pick and choose what they want to do. The business controls how these things happen. So architects are still important, but they have much less control now, and they're more in a type of a governance level than an influencing level in terms of the way IT works. And it's a trend that is happening. It's a trend that I see. It's a trend that happens daily. And it's by no mistake now that I spend more time talking to business and developers than I do architects and operations. And in fact, operations, I don't know if anyone's in the room for operations, but operations seems to be quietly disappearing because it gets amassed into development. Okay, any questions on that before we move on and get onto the main topic? Silence.
That's Iceland. We don't ask questions.
Okay, so let me move to the next presentation. Okay, so let's talk about DevOps then. So I'm going to give you an introduction to DevOps and then explain how we kind of apply DevOps with our customers, and explain what we do and why, and some of the learnings we have around DevOps and so on, to try and give you insight into why we do this, how we do it, and what we find. So DevOps in essence it's the conjoining of development and operations and QA, and DevOps is the bit in the middle, right? It's the intersection of all those things. The last 4 lines here are the most important in DevOps, right? DevOps is not a tool, right? You can't buy DevOps. It's not a tool. It's not a job description. It's not a role. It's actually the way you work and the way you behave and the way you do things. And it really is a philosophical and cultural change and a paradigm shift in the way things are done. So you can't, if somebody comes to you and says, we can sell you DevOps, tell them to go away. Right? You can't buy DevOps. You have to do DevOps, and you have to change to be building things and doing things in a DevOps style. DevOps has evolved over the years, and this slide's great. You can see poor old waterfall at the end is the dawning of man. And if you talk about DevOps, you'll hear things like continuous integration and continuous delivery and continuous deployment. These generally are the most important areas in DevOps. Operations in DevOps actually really hasn't come to light so much yet. So operations exists, but it's still kind of how it was to an extent. What will happen as machine learning gets smarter is that machine learning will take over the operations functionality, and will start to control the servers and the machines automatically based on what it needs to do, based on what it's seen before. So at some point in the future, we'll see operations becoming roboticized to an extent in terms of what software robots can do to drive those systems and so on. So we have, we're going to build it out, a number of foundations on DevOps, and I'll just explain these briefly. But the first is agile development, right? That there is, you can do DevOps with agile, but agile development gives you so much more. There's no point trying to be quick and build things quick and deploy things quickly if you're in a waterfall project and you've got fixed timelines and timescales and fixed dates where you can do things. So you can do DevOps in a waterfall project, and it does give some advantages, but it won't give you that fast deployment. It won't give you the deployment every 300 days in a year deployment, or every 11 seconds. You'll be constrained to your dates in your waterfall project. You move on to build automation. So how do you build the software reliably and consistently and predictable? You want predictability in this. You want to be able to do this time and time again and have the same output. So build automation provides you with that facility to do that and give you that sort of output. But once you've built the software, how do you deploy the software? Do you spend ages trying to deploy the software? Do you do this manually? What if that creates errors? And I'll give an example of the use case of a customer in a minute to show how this affected them. Test automation, there's no point building as fast as you can in Agile, no point automatically building the software and deploying the software if you're going to spend the next 4 weeks testing it with a person, right? Or you've got a person driving the software to actually test this thing. So you have to automate tests to improve the quality, to accelerate QA. And the last foundation is automated provisions. This is around the ability to provision an environment and create an environment quickly and start from scratch every single time and do this. This is the hardest part to reach, but actually containers have changed the game in terms of automated provision as well, and I'll explain that in a little while. DevOps is about that one thing on the screen, to automate everything, right? So business is always trying to automate their business processes. DevOps is the automation of the IT development lifecycle processes, and that's what DevOps is about here. It's about automating everything you do, but also treat everything as code, right? So not, you don't go onto a machine and log in and change a setting on an OS. You don't go onto a machine and log in and change a setting in a software, because if you do, it's not repeatable. You can't repeat it thereafter, and it will get lost next time you do a deployment or an upgrade, or you try and you have a server crash. You've got to then remember what setting you change and go back through again and do that again and again and again. And they will get lost, and that's when you end up then with regression and issues and things that have happened because you haven't treated everything as code. So everything should be treated as code. And the line at the top says it all, right? These things are boring. Developers don't want to have to build and deploy. They want to write new sexy functionality, right, and create things for customers and keep themselves happy using the new frameworks. They aren't interested in testing or in building or deploying. That's the necessary evil that gets in the way. That was for operations, right? They built and then throw it over to the operations team and say, you deploy it in production. The important thing about DevOps is to be successful, you have to have buy-in across the organization. And there was a piece of Gartner research where they asked companies what the biggest challenge for organizations was with the expansion of DevOps. And by no surprise, 50% of the challenge was people. So people are the biggest issue and the biggest challenge to DevOps. Next followed by process, but you'll see technology and information are not challenges at all in terms of DevOps. It's people and it's process. So the only way you will be successful at DevOps is if you can bring the people and the processes with you and change these things to make DevOps work. If you can't change this, DevOps will not work, right? So you've got to actually move forward and get a whole buy-in across the whole organization because it affects everybody. So why DevOps? Now we know what it is, why. So if we look at waterfall development historically, the business would create a set of requirements, right? They would write up their requirements and they throw them over to the developer. The developer would take one look at them and think, I don't really understand this, but I'm going to build something anyway. But you've got a hard wall sitting there between the business and the developer, and they talk to each other sometimes, but they don't understand each other. They don't understand the business logic. The developers don't understand the business logic. These people don't understand what developers can do, so you get quite a bit of contention there. And then developer then hands it over to test, and test, again, we'll pick up the application, not really knowing what it's doing, we'll test it and we'll understand why it's been built and the way it's built, we'll understand the history, and then there'll be contention between test and development. And at some point, once it passes QA, it will get thrown over to operations and they'll deploy it into production. And that's your classic waterfall lifecycle. So agile development changes a little bit. So agile development brings business development and test together into the sprint teams. So you've got a product owner working with the sprint teams, specifying the requirements with the sprint teams, and they all work together to produce the right outcomes. And testing is included in the sprints as well. So that broke down a few of the walls. But there's still one wall remaining, right? Even with agile development, once you've built something, you've got to get it to operations. So there's still a firm wall between there and there. And that's what DevOps seeks to address. So developers, they want to enable the organization, right? That's what they want to do. So they want to do something to enable the organization to innovate, to further what the company does. And they're motivated by new shiny things, right? The next new framework, the next new language, Kotlin, Go, whatever, right? That's what motivates the developer. They're motivated by what's on their CV, right? They're motivated by what makes them look good in Twitter or on social media, right? That's what motivates the developer. And they just want to go faster and faster, right? They want to do more of these things faster, take on more technologies, deploy more things much more quickly. Operations, on the opposite side, and I hope no one's in the room from operations, want to protect the organization, right? They can't afford to have downtime because they're responsible for those systems. If your main ERP system collapses in a heap, operations are responsible. And if it brings the business to its knees, that's operations' fault. So their first instinct is to protect the organization, which actually means that they crave stability, and that's what keeps them going. They want stability. They don't want change. They want things to be stable and consistent. They don't want to change the organization because with change comes risk, and with change comes instability, which might break the organization's model again. So operations want the stability, which means for them, they want to go slower. And you'll see across each of these periods here, it causes like an antagonistic rope. So the tug of war picture I had earlier, right? There's always a tug of war going on between development and operations. And because if you overlay the business into this, the business want to go faster and faster as well and have different aspirations. So DevOps actually blends those two together. And DevOps then should create the successful organization. So development and operations. DevOps joins development and operations together to allow them to work together and really drive the organization forward at a pace. And we saw this slide before. So DevOps gives you the ability to do these things quickly. If you don't do DevOps and you're fighting with operations all the time to get something deployed, you're going to be at maybe 1 or 2 a year, right? Not 300 a year, not every 11 seconds. So customer example. I mentioned these people earlier, right? So Walgreens Boots Alliance. This is an actual real example. They implemented a complete DevOps CI/CD deployment pipeline, continuous integration and continuous delivery. Before doing this, they had a 80 to 150 page Excel script which they would deploy over a weekend, and they do it on a 24/7 basis. So they would deploy a big application. They'd have people on shifts following through an Excel spreadsheet, following each task line in turn, and then when they get to the end of their shift, they'll hand the spreadsheet to the next person, say, I'm on step 52. They'll carry on 52 down to 80 or whatever, then somebody else will do it, and it took them an entire weekend to get a large application deployed into their environment, which is pretty scary thinking about this, right? What's worse is because it's manual, so they would do things like create directories on machines, create queues in messaging providers, create different configuration files or change configuration files by hand. And because they're doing that, it's error prone, right? Because they're people shifting across shifts across the weekend, not really knowing what they're doing, just following the script blindly, so they don't understand why they're doing it, they just know what they've got to do. So it causes lots of errors. And then, you get to the end of the deployment over the weekend and nothing works, and they wonder why, and they have to roll the thing back. And then you have to literally resort to backups or whatever, or spend the next day trying to figure out why it didn't work. And this was a real example, right? They built the full DevOps pipeline, and they're now down to 15 minutes. So what took them an entire weekend lets them do a full deploy of that complex application in 15 minutes. And it guarantees the stability and reliability because now it's all automated, so there's no person anymore doing that job, let alone the people effort that they had in place. So 15 minutes from 48 hours is an immense improvement. And again, you can see, if it's taking 48 hours, how can you do, 300 deployments a year, right? You can't because it's too risky. If it's taking 15 minutes, if your deployment goes wrong, it takes 15 minutes to redeploy the previous version. So you've got an immediate rollback in a smaller timescale to be able to do these things. The other example is the British Army, where I've spent about 4 years of my life as well recently. They have ingrained Agile and DevOps into their culture now firmly. DevOps is important to them because they have rigorous deployment procedures and rigorous security procedures, as you can imagine. So the British Army have bases in Afghanistan and Iraq and all sorts of places like that, and those machines connect into the secure network, and therefore anything that's deployed in the network has to be rigorously secure, because if some person managed to get hold of the machine and log in, and they could wreak havoc in the network, it would cause problems. So they use DevOps to control the onerous deployments and the security processes. They've got security processes within DevOps to guarantee what's being deployed isn't going to create any security issues. So DevOps is a cyclic process, right? So you start on plan. So you would do your analysis, your user stories, your prototyping. You move to create, which is where you do the design, the development, the testing processes, the quality processes, security. Verify is around testing and acceptance. Accept is the whole cycle around QA and performance test and UAT, and then packaging up application. Release comes down to deployment and then change control and rollback, because you might roll back. And again, this is important with DevOps. If you do a release and it's wrong, you can roll back very quickly and almost immediately. You get to configure, which is around change control again, and you get to monitor, where you monitor the performance, the user experience, and the infrastructure. So what I'm going to do is break down each of these into physical stages and show you how this works. So we start with Agile development. So I showed some of these slides earlier to an extent. You see, two-thirds of organizations recognize that Agile has improved the frequency of the product releases. Two-thirds, and there's no surprise, right? Because Agile should improve the frequency at which you do things. The stat that surprised me was this one here. 61% of organisations says Agile has improved the staff morale, which I was quite surprised by. But this is just taking Agile on, right? And you can see over this one here, nearly a quarter of organisations found that Agile has reduced their project costs. This is just taking on Agile projects. If you look at DevOps, 81% of organisations saw an improvement in the ability to deliver value to customers, right, and deliver on objectives. 81%, so it's a massive throughput. The biggest one that's interesting here is this thing here. Improve lead time from commit to deploy, 440 times from commit through to deploy, which is a massive leap. And the other two here are around time spent on work. If you join Agile development and DevOps together and then look at those same stats, you can now see that rather than 2/3, 3/4 of organisations report that Agile and DevOps has improved their business IT alignment. So you've gone from 2/3 to 3/4 in terms of productivity. And you see down here 64% of organisations has also reported that it's improved the technical quality as well. So not only improving the speed and reducing the costs, it actually improves the technical quality as well, because you become more rigorous taking an Agile approach and a DevOps approach. So Agile development, what are the requirements, right? So Agile development requires you to be able to build things locally, so you can develop locally. You need source control, you need to unit test, you need to code quality. I'm going to walk around this cycle a little bit. So we'll start with analysis, develop and change code configuration. This is where you do your analysis, right? You do your coding, you put in configurations. If you want to change a configuration item in a piece of software, you write a script to do that, and you commit that script into source control. You don't go and do that manually, because every time you do the build, you need to make sure that configuration gets reapplied, otherwise it will get lost. So you code all those things in. Then you build unit tests. So you could use JUnit, which is this example here, right? You could use JBehave, you could use any sort of behavioural driven testing to build unit tests. It's important you can do things like code coverage, right? Because you want to know how much of the code you've covered with tests. So in this example here, you'll see I've covered 70% of the code base with tests. And you have to work out a metric which says, is that good enough or not? You can't always cover every single use case in a test, because some aren't actually repeatable. There's conditions where you might catch an error that never happens, for example. But you want to have a metric in place which says, for example, if I've covered, say, 75% of my code with unit tests, then I'm happy. And up until that point, you won't let it go past the build until you've hit that number of unit tests. So then once you've built your unit tests, you build your end-to-end tests, right? Your interface tests, your performance tests. So examples here, right, is SOAP UI, Cucumber, JMeter, for example. Different tools, doesn't matter what you use, you build these things, right? You could be using the HP suite, for example, or whatever it may be. But you build these things as part of your Agile process. You should extend tests for every feature. Every time you do something, you should build a test for it. You should never not write a test, because otherwise it's going to be untestable, and therefore you can't predict what's going to happen. The aim here is to write tests for everything, because then every time you do a deploy, it gets tested automatically, and you know it's going to work or not work, or you know whether you've introduced regression. One of the important things here, right, is you can do it the opposite way around. You can write tests first and satisfy the test with the code. So your test can follow up from your requirements, and can be based on your requirements, and you fill those tests with the code to make it happen, right? So that turns it on its head to ensure that what you build complies with the test, and what tests comply with the requirements, and so on. So you can do all those things. The other important point on this slide here is you should use mocking features, because when you're testing, you don't always want the things to go to the end systems, right? If you've got an SAP, for example, you don't want things ending up in your SAP, and you're not really trying to test SAP as an example, right? You're trying to test the thing that calls SAP. So you can mock out the responses using the features of the testing tools to avoid that happening across all the environments. And it even means you could test in production if you wanted to, because you could enable the mocks in production and have the test run in production if you're brave enough. If you're brave enough, yeah. And then you get to things like quality processes. So here, you want to be able to have development time quality processes. You want to check the quality of what's being done. And there are tools for this that exist as well. So for example, this is something called Sonar Cube here. This is a piece of software AG technology. This is open source, but it allows you to check the quality of what's been built. Because just because something works doesn't mean it's built in the right way. And therefore you check the quality. And the reason you do that is because 80% of the lifetime cost of software is in maintenance. And if you can build it in a maintainable, right and consistent way, then you will reduce that cost over time. So therefore you have to put in a process in place to ensure that nothing can be committed that doesn't comply with your standards and your quality of code that you expect. And then once you've done all that, then you check in to source control. The point here, right, is with Agile, you haven't finished when you commit things, right? Once you've sorted out all your assets, you don't finish. You finish only once you've got things like the unit tests in there, the interface tests, the end-to-end tests, performance tests, any deployment and migration and configuration scripts. Only at that point is your definition of done satisfied. So all those things have to be done before you can mark your user story as complete. And I won't go through this in any detail because you'll get the slides. But in essence, this gives you two views on the strategy for source control. So you need a strategy in place when you're doing source control. The most important thing here in DevOps is to commit frequently. Don't commit once a month. Don't commit once a week. Commit frequently, daily, because people want to get the changes immediately and understand what those changes are so they don't have any impact. So we next move to continuous integration. So continuous integration is a software engineering practice where the minute you change a piece of code, the minute you commit something to source control, it will be pulled back out and tested immediately and reported back if those tests fail. But it's not just tested, it's quality checked, it's tested with the unit test, it's tested with the interface test and the end-to-end test. So the minute you change a single thing, it's pulled back out, deployed back into the larger code base and tested again. So whenever anyone changes anything, it's tested straight away and quality checked straight away. And therefore, if I'm having a bad day and I change a piece of code and I cause a problem, the problem will be highlighted straight away, and it will give rapid feedback to the team, the whole team, saying, Dave's done the thing again and broke the code. And Dave has to stand there in front of the team and say, sorry guys, I'm going to fix it right now. Because it opens up my name in lights saying, Dave broke the build at this point. And therefore, it educates developers actually to be better because they don't want to be exposed as causing the problems and blocking the build. So this gives you immediate feedback. Now, the way this works is once you check in code, you then run through the same quality processes, right? So the same quality processes that developers should do, it should happen automatically. And at this point, if the quality isn't good, it will stop the build process and kick it back and say, actually, your code quality is not good enough, it's not acceptable, therefore you stop the build. And again, if I've done that, it will flag an email up to the team saying, Dave's doing rubbish code again, time to go and fix it. And therefore it encourages you to do better coding and build things of a better quality. But once you've got past that gate, it does an automatic build, and then it will deploy into a build environment. And that deployment drives the assets into an environment where they can be physically run. If you've got an asset catalog, it'll be published into the asset catalog, but then you'll do a whole load of the automated testing. So all those unit tests, all those end-to-end tests, all those things occur. So you've done your quality tests, you've done your tests, and this cycles around every time you change something in the development process. Every time you commit something, it will cycle around and test it again and again and again. And therefore, if you build new things, but you change something historical, you might create a regression, but you'll know then from your unit test that tested the previous thing, you've caused a regression, and then you have to go and fix that. So it gives you immediate insight into the problems you might create by doing things. And to do that again, you can use things like Sonar Cube, same principle over here, that create reports on the quality processes, and you can use something like Jenkins or Team City or Team Foundation Server or a multitude of other different CI software to be able to automate the build and the deploy. And in terms of your testing, again, here, you can expose in the CI process reports. This is a unit test report, this is a cucumber report. All these things on the screen are all consumed within, in this example, Jenkins, and are exposed out and visible. So anybody can look at the build and can see the unit test, they can see the end-to-end test statuses, they can see the code quality statuses, and by anybody, I don't just mean the development team, I mean the business and the management team as well. So everything you do is exposed upwards so people can actually look down on the project and work out what's happening. So again, it encourages you to do better, to kind of keep yourself safe. And then once you've done continuous integration, you move to continuous delivery. And this here is around the automated delivery of assets into the environment. So now we cycle around the CI process. At some point, we decide we're going to do a release build. And quite often, that's a manual decision. So at that point in time, someone's going to say, actually, we're going to release version 1.1 of a component or a piece of software. And you make that manual decision. When you do that, the first thing it does is it will create a version piece of the code. So it will branch source control. It will put it in as version 1.1 of source control. So you've got a copy of the code at that point in time. It will then build a binary of the code at version 1.1, and then we'll put that into a piece of config management software. So let's say JFrog Artifactory or Nexus or some other piece of software where it will store the physical asset at the version that's been built. So if I've just built version 1.1, I'll have version 1.0 and I'll have version 0.9 and 0.8 all stored. It will then deploy that physical binary to the next environment. So it could be UAT, for example, or a QA environment. It will drive the binary into the environment, and then once it's done that, it will run all those tests again. So all those tests we had in here and we built down there, they're now running in the next environment. So you'll find out if there are environmental factors. You'll find out if something doesn't work in that environment for whatever reason. The important thing here is when you deploy that version 1.1 here, if these fail and you deploy this to production, you've got version 1.0 sitting there that you can pull back out and press deploy again, and it will just drive that version into the production environment again. So you've got a quick way to deliver binaries and code into environments that is repeatable, that requires no human intervention other than the button press to make it happen, and you can work at a pace where you can deploy and roll back. And then the last phase of DevOps is automated provision. And I said this is one of the hardest ones to achieve, but it also gives you the greatest gains, right? It's like Peter Parker's father in Spider-Man, right? It's with great power comes great responsibility. Here you have great power and responsibility in this, but continuous delivery works best when you have a blank canvas, right? What you don't want to do here is assume previous state. You don't want to assume when you do a build that this configuration is being changed, that this exists, that this exists. If you assume all those things, your builds don't become repeatable. So you can't make any assumptions on what's in that environment. Otherwise, the build has to have things run in order through circles to get to the point where it needs to get to. So you can't assume really the state of a system if you want this to be repeatable. Historically, the provision of systems was done through things like Chef, for example, a piece called Chef, or using virtual machines. So you could spin up a virtual machine, install the OS, deploy the software into it, and deploy your things into there, and you could do that. But it was cumbersome, to say the least. It could take you half an hour to create a virtual machine in a cloud environment or even in your own VMware space, to install the OS, to install the software. And you have scripts for all those things, but it can take a while. So it does give you the way to create this clean state, and it gives you the ability to elastically scale, right, as well, because if you do this, if you need another server, you just spin up another one and another one using the same processes. So now you can suddenly create more scale. So the thing here is containers make life much easier now, and I'll explain why. So you take a machine of some sort. So let's say this is an Amazon AWS instance. We take a machine. What do we have to do? We have to install the operating system onto it. Once we've done the operating system, we have to put in configuration to the OS, right? We change some certain settings in the OS or whatever to harden it or all those other things. If we're going to, say, build a Java app, we need to put a Java virtual machine on there. Or if we want to do a .NET app, we need to put a .NET runtime in. That thing has to be installed next. Then we install some software on top of that, right? So now we put software in place. Then we implement something in that software. So now we're going to start implementing things in the software, and then we configure it, right? So we have to do all these things into a machine, and all of these layer on top of each other, and you have to do these in this order to get the software working. And of course, then if you need more machines for high availability or for scale, you then duplicate all those things again, right? And then you might have that connecting to databases or a data lake, and then you've got a whole range of connections. Now, historically, when you deploy things like configuration there, the implementation here, the configuration there, but you don't deploy the software. You assume that's built in already in place. You assume the OS is already in place. And you have to do these deployments on each of the machines where you're trying to change this thing around. You have to do changes over here as well, for example. So that's the historical way of doing this. Docker came about a few years ago, and Docker changes this process, right? So Docker will let you containerize each of those layers, so they all move into a single Docker container. And Docker container, by no accident, looks like a shipping container because that's what it represents. So you can put an entire system, including the software, including your configuration, including your deployments, into a container. And that now is a single package container that you can run anywhere with your exact configuration of your software. And if I want to now deploy this into different environments, then I can literally replicate the container now. So now I don't have to do another deploy, I just move the container and create a new version of the container, because I can scale out now by copying, duplicate this container, and the container doesn't care whether it's running in Windows or in Linux or in a data center or in an Amazon virtual machine or an Azure platform or whatever. Like, the container doesn't care. It really is a black box of software now. You put the container on there, it runs, and it just does what it needs to do, which includes all of your changes. So DevOps allows you now to not only build and deploy the software, but to actually build a container and deploy the container. And you know, after the presentation, if anyone's interested, I can run and show you a live demo of this thing working if anyone wants to hang around and see it. But in essence, you can take all your software assets, wrap it into a container, drop the container into production, and then it's as it was built in the previous environment, and you can move containers through environments and control them. You can get even more clever on containers. So you can use things like Kubernetes, which is a Google piece of software, or OpenShift by Red Hat, or Pivotal Cloud Foundry, which has got Kubernetes in it as well. And each of their software allows you to control how the containers work. And the software allows you to automatically scale up and scale down. So it can check the containers, can check if they're busy, and can scale outwards and create more containers when they're busy, and then pare back when they're not busy. But it also checks the health of the containers, and it can check the health and can automatically restart them if something goes down, or create a new instance of the container and just kill the other one and just lance the container that's gone rogue. So Kubernetes gives you all that ability, but it also gives you the ability to create pods, and pods let you create containers together. So you might have a container which does a user service, and one which does a product catalog, and those things need to go together to make sure they're both active at the same time, and a pod lets you collate those containers together, and you can have multiple pods. You can take it even further, right? So you can then start doing things like blue-green deployments, and if anyone's heard of blue-green deployment, in essence what it means is normally you say you're on green right now, so green is your live environment, so green is running here, here, and here, and that is your live instance, and blue are inactive. In essence, they're almost pre-production, and you can deploy into pre-production and just switch, and that becomes the active environment at that point in time. So you've got the ability to deploy into an inactive container or an active pod, and then just flick the switch, and that becomes the production environment at that point in time. And then this one then gets turned off. You update that one, and that becomes the pre-production environment. So containers and pods allow you to be much more clever to give you a true high availability, high scale environment to really drive forward the organization, to avoid downtime and avoid any issues in terms of where you are. The final point, we're good for time, is monitoring. So the last bit of DevOps is around monitoring. As I said, monitoring is often forgotten in DevOps. But in essence, monitoring sits down here, right? So once you've deployed the next environment, you apply monitoring techniques to watch that environment. And there are a whole load of new monitoring tools that exist that we can go into that kind of explain and monitor containers directly now. So you can monitor containers directly. You have to learn from those things, and this is where the robot comes in at some point, because what you want to do is learn from the problems and then drive that through into your development processes to improve that and connect the two together. So when you identify a problem here, you don't just fix the problem in production, right? You identify a problem in production which says, we've got the database name wrong, right? You don't then go and just change it in production. You change it back over here, and you deploy right through in 10 minutes or in 15 minutes. And you drive it through from front to back through the environment as quickly as you can. You don't tweak in production, because if you tweak in production, the tweaks get lost, and that's dangerous, because then you can't repeat what's happened before. And if you take this whole approach, if you had a complete disaster, as long as you've got your conflict management catalog and you've got your build scripts and processes, you can press run. You can rebuild a complete production environment, just from those assets in minutes. So almost your strategy of having to have kind of a DR type approach becomes redundant to an extent, because your DR is the fact that you can rebuild these things at such a pace, and that's how Amazon managed to do their deployment every 11 seconds, right? Because for Amazon, a deployment might be something small, and something small can run through this process very quickly. Something large takes longer, right? Because something large, if you've got lots of tests around user interfaces, they take a while in the automated testing phase to drive the user interface. But if it's a small microservice, and your microservice has a couple of APIs in there, actually you can change and deploy that microservice all the way through put it into a container on its own and move that container into production within minutes and have that change there and ready to go. And as I said, if you get this wrong and you find there's a problem, actually you can undo the change and redeploy the previous version within seconds as well. So you can drive these things through, all the way through to production quickly, and really innovate and change the way you work. And that's what DevOps is really about. DevOps is around having the ability to drive these things through the environments fast and quick, to provide the ability for you to innovate at the edges and not fall behind the likes of Amazon and Netflix and all those other companies that are baying at everyone's legs right now, trying to work their way up through the world, the big US companies, right? And even with the fire alarm, we're on time. Any questions on DevOps? Take questions from the floor. I said I'm happy to demo this if anyone wants to see it as well.
Well, the challenges, DevOps.
Yep.
Or the biggest ones.
The challenge is people and process, right? Without question.
But, yeah, I remember this
Yep.
slide, but I think it just want to kind of, I know it's people, but
So it's the same challenges with any IT project, right? It's people's inability or people don't want change. People don't like change, right? We're all people, right? None of us like change. Every person likes stability and repeatability. That's how human works, right? You like to do the same thing day in day out ultimately, and any change threatens your existence, and any change makes your life difficult. DevOps actually in some ways are the people. If you can get development and operations interested in this thing, they'll ride with it because it makes their jobs better. It changes what they do slightly, it changes the way they work slightly, but for the better, because they're not doing the boring things now, they're doing the value add things. So you have to bring the business forward. The other problem here is the business, right? Because the business don't always want the risk, right? You can deploy in 5 seconds, but the business won't let you deploy, right? They'll say, God, that's too risky, right? We're not going to do that. We'll deploy once a year or every 6 months because it could cause an issue, right? But the thing here with DevOps is, and again, I don't know if any of you heard the term bimodal development. So bimodal development is recognized ways of working. So there are two ways of working. One where you have a steady base, which is like a waterfall type project and systems that you can't change, and one where you work at the edge, where you work on the innovation space. So things like customer-facing apps on a phone, a website, things at the edge of the business where you can really innovate your experience. You can change those things very quickly and very fast. What you can't change so quickly and so fast is your ERP system, for example, or your product system, or your CRM or whatever. Right? Those things innovate at a slower rate. So you apply DevOps on those in two different ways. So with the innovation systems, DevOps really shines because then it changes these things fast, right? So you want to roll out a change to a mobile application that lets customers see their bank account, right? You can do that in seconds and have it live. And if you get it wrong, you can, which UK banks quite often do, right? You roll it back and put all the previous version back in. With your ERP, you can still apply DevOps principles, but it is at a more constrained rate. So you still do that, but there are still gates where people want to control the flow. And so you have to kind of take the business with you a little bit, and you have to differentiate what you're trying to work on and why, because there isn't one shoe-fits-all type approach to it. That makes sense? It's a good question.
So is the first step then for organizations to basically just educate the operations and development teams of how to work?
Yes, no. So just to repeat the question, then you said is what should the organisation do as a first step? To be honest, a lot of organisations do this already, but they don't realise it. The development team probably already work in this way to an extent. You might find dev teams use Jenkins, for example, to do builds and things, and you'll find pockets of DevOps, but no recognition that it's happening. What you have to do is educate the business to create the recognition that this thing happens and to explain why you're doing it and what benefits you'll get from doing this. Because it's a very technical thing, right? It's a really technical thing doing DevOps, but the consequences of not doing this and the impact of doing this are far greater to the business than they realise. Every business is an IT software company ultimately, right? Everything we do is based around IT as businesses. No matter whether you're a logistics company or Amazon. Every company has IT at its core and heart, and if we all use the same software, we'd all be the same company, right? But we don't. We try and create ourselves to be different and look different and behave differently. And DevOps is firm and centre in there. So you have to really educate the business to allow them to understand that process and make sure that they can go on that journey. DevOps, you start small, right? You don't have to go all in. You can start small. It's cyclical by nature anyway, so you can start small and grow out the use of DevOps across the organisation. So you can just take, say, one microservice and DevOps enable that, and then start to grow it out from there. And that's how most companies work with this. So they don't start en masse. They don't say tomorrow we're going DevOps everywhere. They introduce it into one project and then roll that out, and then the use of it grows across the piece.
Most companies are only starting to look at containers, or have a
Yep.
container projects up and running. How important is containerization to?
So it's a great question again. So how important are containers to companies? I'm not going to beat around the bush, right? It's changed what software do you do as a business. Our software, gone are the days of big installs, right? So we would say to create an architecture that would take a few weeks to come up with place. We'd spend time installing the software. No more, right? You can take an AWS instance, deploy Kubernetes into it, and then take a container of our software from the AWS marketplace, and it's there ready to run. It's massively changed what we do as a company, and it's changing what other organisations do. Now you're right to point out that businesses are just catching up with this. It's the bleeding edge of IT right now. I mean, containers have been around for 2 or 3 years, but what it means is you can now truly create deployable units that you don't care where they run, right? And that means you don't have to think about how to install the software. Should I care whether software AG software works on Red Hat Linux or Windows? Do I care whether I need .NET runtime? I shouldn't need to think about any of that, right? All I do is get the container, drop it in place, and it runs, and the software's there, right? It doesn't matter what technology it uses, what OS platform it's running on, and that's the real beauty, and that's what's changing the market, and that's why it's changing everything we do. To an extent, virtual machines did this, right? 10, 20 years ago, whatever it was. Containers are another level again on top of that, and you'll find companies mix containers onto virtual machines as well. So the virtual machine strategy doesn't go away. You still have your virtual machines if you're using your private cloud, but what you do then is deploy Docker or Kubernetes into there, and then deploy containers into there afterwards.
But the correct approach, if you're going to go the DevOps way, is not like you don't buy expensive complex machinery and put it in place, have it operational, and then train and educate the people to use it. You do it the other way around.
Correct. Yep.
So
you grow it out from the inside.
you need to start with the people and the processes, and then they thirst to get the equipment that they need to make it happen.
No, exactly that. So just to repeat the question, it's kind of how do you start this, right? And Walgreens Boots Alliance is a good example that I use. That was their first DevOps process they fully enabled. They identified a problem. They identified the fact that it takes them a whole weekend to deploy. That wasn't actually the problem. The problem was the errors that it caused and the panic it caused in the business the following week because of all the problems that were created by the deployment. So the actual time wasn't a problem to them because they just outsourced that deployment to an SI. So they didn't really care about the time. They just let that happen. They cared about the business continuity issues that it created afterwards when there were problems. And they used that as their first DevOps initiative because that had true business value. And that was something the business could see and understand, right? So the fact they can deploy now without causing all those issues in production gives them that drive. And they did that from the inside out, right? So they found a technical IT problem that causes issues for the business, used that as the driver, and then actually didn't really tell the business they were doing this. They created this from the IT side forward and pulled it through, and then said to the business, look what we've done. And now the business realised that it makes a difference, and they're starting to roll that out across other processes and other development projects across the piece. So they did it exactly as you described, right? They found the problem, they fixed the problem and rolled it through IT up to the business, and then went back to the business afterwards and said, actually, this is the output of what we've done. And actually didn't take long to do either, right? DevOps doesn't take long to do. It's just about changing the way you work. So for those who are interested, I'll just show you a quick demo of some of this and show it working. DevOps it's kind of invisible, right? You don't see this thing happening. So I'm just going to give you a view under the covers about the way this works. So here I have a CI pipeline and a CD pipeline. So this is building a simple test system that we put together to demo this. And my CI process looks like this. So it sets up the project, it builds and deploys, it does a quality check, it does unit tests, it performs interface tests, performance tests, and security tests. So whenever I change something in the code, it will go through this entire procedure. Now, because this is a demo, I don't have it automatically triggering off, right, because I want to control this thing, so I kick it off manually every time I want to test this thing out. If I hit build now, what you'll see is this will take out everything out of source control for that project. You can see it over here, going along, and just to show you this view, press over there. What you'll see is the process around the build. So it's going to run through each of these jobs in turn and show you what it's doing. And if I go back to this view here, you'll see where it is in the process, right? So it took 9 milliseconds to set it up. It's now doing a build and deploy. So it took 25 seconds to build my project and deploy it. Now it's deployed it, it's going to do a quality check against the deployed assets. And it's going to take, on average, around 20 seconds or so to complete the quality check. Once it's done that, it will run unit tests. So the quality check was quicker today, look, which means my machine's quieter. It will run through the unit test next. So now it's checking all the units of the systems, and I'll give you insight in a second into how these are done. So it's not very exciting, right? But DevOps shouldn't be. You shouldn't see much of this. This just happens behind the scenes. So now it's done the unit test. It's now on the interface test. You can see we're actually quicker today. Okay, and now it's going to run performance test. So not only am I checking the units, checking the actual interface, I'm performance testing this as well. So this is a call out to get a weather service. So it's checking the throughput rates to make sure they are as I expect. And then finally, it does a security test. So you'll see this build's now complete, right? So this is my CI pipeline done. And if I look, say, into the quality check, you can take a look into there, and you can see there are no failures. And this is the quality check of the code that's run through. And you can see this either as a console output, which is a bit technical, that shows you the actual view, if it comes back. Or you can browse into each of the tests in turn. I'm going to get disconnected. Okay, if I go back, oh, I've lost Wi-Fi, look. Hold on. Let me just reconnect back on. VPN reconnect. Hopefully.
Demo gods.
Demos, yeah, always right. Something always goes wrong. Okay, so if I come back again, hopefully, there we go. So that's my quality review. Actually, as well in the quality review, what you can see is even down here you can see the trend. So you can see here the red ones are failures, right? So if I press just show failures, you can see here where the failures were in the quality review. And this is all information just published back in standard reporting metrics into Jenkins. But again, as I said, you can see actual physical reports also. Here's the physical HTML report of the code review as well. So everything's open for everyone to see and to look at. That's the quality checks. If I hit back into our build and look, say, at unit tests. Okay, so wrong place. Okay, unit tests. Let's pick something interesting. Let's go performance tests actually. Let's look at performance tests. Okay, so you'll see here, in terms of performance tests, we can see the results that come back out. If I go back at this level again, what we'll see is, there we go. So you'll see the metrics fed back out of the performance test as well here. So you can see if I get my VPN out of the way somehow without killing it. You'll see when I first did this, right, I had problems, so I had 100% errors. You'll see now the errors have gone on subsequent builds, but you'll also notice that when I had errors, the response time was great, right, because it was doing nothing, so it was responding pretty quickly. But the minute I introduced the actual call, you can see the response time shoot up and go across, and you actually see more recently it's getting, the average is decreasing, right, so we're actually getting a better response time the more I do this. But again, all this is published in by running the tests as part of this continuous integration process to allow that to happen. And that just, again, drives through the quality that you're interested in. And if I pick, say, interface tests again, you'd see similar again. So all this information is all wrapped up into each of these builds. So that's my CI process that I can find. And just to show you, for example, the build and deploy logs, so you can see that. It's not very interesting, but I'll show it you. You'll see here, it gets all the source code out from, this is Subversion. It gets all the source code out of Subversion and then runs through the entire build and deploy process. And at the bottom it says, finished, success, right? And if any of that failed, it will stop the build. Okay, so that's the CI process, and that's constructed in this example of lots of individual components as well. So this is the individual component, and you can take a look at that, for example, and you can see how the job is constructed. And the way CI and CD tools work is you construct via command line calls pretty much, or REST calls. So you'll see if I go down here, that's where I get my code out of source control, so it pulls it out of source control, and then thereafter you'll see a series of commands which are run. So it will first just write out what it's doing into the log. So if anything fails, you can see where it was in the log. Then, ignoring that line, so it's not interesting, it runs through a series of different command lines to build and deploy that project. So these are shell scripts that it goes through to do that process. And the final one down here is the build to deploy into the environment. So all those jobs are all sequenced together to actually create the deployment process themselves. So, and it doesn't matter whether you're doing web methods or .NET or Java projects or whatever, right? You do this in the same way. You might use, if you're doing Java, you might use Maven, for example, or Ant. You would use whatever is appropriate through the command line to call to be able to do that job. Okay, so having shown you the CI process, we can get to the release process. And let's run this one first. So this is the release process, which looks very similar, right? If I run a build on this, we'll see in here it's asking me for a version now, so I'm going to go version 13, 13.0.0.0, and I press build. And what this will do at this point now is it will now run through a similar process to CI, but it's now going to build me that particular version of the code. So it's going to label and branch source control. It's going to build the binary, and at the end it's going to put the binary into the binary repository. So it's creating me a physical output now of this build process. And you see this takes slightly longer than the previous job because of the fact that it's got to now register the build binaries, for example, but it still does the same things again, because you don't want anything to creep in here, to go through that process of actually creating a final binary. Once that binary is complete, it will end up, I'll show you here. Oh no, I've dropped out again, look. Give me a second. Reconnecting. Okay. Once those builds are complete, you see in this example I'm using Nexus to track what I'm building. So if you look at Nexus in here, I hit that one. We'll see in here, all the versions of software that I built over time. Everything is in here, right? So you get the actual gzip file, an MD5, an SH1 file to check it against, and any version I've ever built is held within here. And at some point along the way, we'll see version 13 come in below there, right, when it's finished building, which means I can then redeploy any of these versions back in the next environment. So this is the job that's building that actual physical piece of software, and this one's nearly finished now. And it'll be done in a second, and version 13 will exist there. Now, take it a stage further. Rather than just compiling the software and building a binary, I can build a container. If we look at this example, I'll show you this in here. This example here goes through the same process as before. You see this how it creates the stage jobs, but this builds a container. And if I look at the container job, this one here, you'll see the way we build a container is again through command line scripts. So we go into the right directories, we create the Docker file, we create the actual image itself, and then we overlay the configuration of what I'm doing inside that same container. Once we've built the container, we then simply do a Docker image save, give it the name, and create a tar file, and then we throw the tar file into our repository. Now it could be Docker Hub, it could be Nexus, it could be whatever, doesn't matter, but you take the same approach. We build a container, we zip it up, and we put it somewhere so we have that container to build. If I built a container, you'll see back in here, that one. Okay, so you'll see here, you can see how long this job takes, right, roughly. If we look at the container job, you'll see right now it takes around 10 minutes to build the container, because my container is around 1 gigabyte of size. It's got CentOS, there's a Linux base in there, and it's got some software in there as well, plus what I deploy in there. So it's around 1 gigabyte. It takes around 10 minutes to build that container. The slimmer the container, the quicker it is when you build the containers up, because it takes around 10 minutes. You can even see here, look, where I failed something in the past, right? So you can see a failure there on failed unit tests and so on. Now, having done all that, if I go to here, so we'll see I've got a container at version 12. If I go to this environment, okay, all I need to do to deploy into production is this. So I take the version number of the container I want to deploy, I pull the container out of Nexus using wget at this point in time. So it pulls the right version of the container out of Nexus and then simply does a Docker load with the container. And that's all I need to do to deploy that container into that environment. So if I wanted to run one of these now, I could say, let's deploy version 12. So we run the job. Version 12, 000, press build, and that will go off now, and we'll deploy that container into my test environment. And you'll see if I watch this thing, it's failed, right? So it's failed because it can't find version 12, so I need to give it the right version number, for example. But all you do is give it the version number of the container you want to deploy. As long as it's there, it will pull it out and do the deployment. And then we'll drive that downstream into those environments. Okay, and you can see again here how long that takes. So it takes me generally just over a minute to deploy a container, because it doesn't take as much time to get it out there. So once I've got the containers built, if I need to roll back, it's going to take me just less than 2 minutes to be able to roll back to a previous version of something I've built. And that container's got not just the OS and the software, but everything that I've done to the software inside it as well. So all the configuration. If it's a .NET project, you've got your .NET runtime plus whatever you built in .NET, plus the config files, plus whatever that needs to talk to, and all the different assemblies it needs, as an example. If it's Java, you've got all the server things you need within that project, with that container, and that runs independently in its own right. I could log into the machine and show you, but you literally just run Docker. I think on this machine, maybe, we'll see. on this machine we've got something called Portainer, and Portainer gives me a view on the containers on this machine. So see I've got 2 containers in here. Yep. And that is my deploy container, by the way. Ignore the names, Docker generates them itself. I mean, hopefully that gives you an insight into the way this can be done. It was useful. Any questions?
Don't ask questions.
I always ask questions. Nobody in the UK gives any questions either, by the way. So that's why I always offer it up, just in case.
Thank
Thank you.
you, Dave.